My name is Nur Amira binti Muhammad Ali and my metric number is 156120. I'm from group B11 and the experiment is S1 Torsion. So the objective of this experiment is to apply torsional moment for bars with different material and find the corresponding modulus of rigidity or shear.
Hi, my name is Alia Shazana binti Faiz Bahri and my ID number is 15960. So today I'm going to do a torsion experiment, so let's get started.
Hello, hi, my name is Fatina Shafika binti Abdullah. My metric number is 155990. I am from group B11. So today I would like to do a torsion experiment. So let's start it.
Hi, my name is Muhammad Iqbal Rosmadi. My metric number is 160026. I'm from group B11. Today, I will do some experiment. Okay, let's go.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Alif Iman bin Muhammad Fauzan. My matrix number is 159587. And today I'm going to conduct the S1 experiment. S1 is all about torsion. So the objective of the experiment is to apply torsional moment for bars with different materials and to find the corresponding modulus of rigidity or shear modulus. So for the introduction, torsion or torque can be defined as a moment that is acting upon an object around the same axis in which the object lies. A moment is a measurement of the propensity of a force to create motion around either a point or an axis. Torsion can be calculated as the force upon the object multiplied by the distance of the force from the chosen origin.
The apparatus is load, span stick, rope, protector, cardboard and chopstick.
The apparatus that we need is rope, protector, tape and scissor, wooden stick, box, and 40 grams of stone.
Apparatus for this experiment is rope, scissor and tape, wooden stick and box, protractor and ruler, and lastly is battery.
Okay, for this experiment, we use CD, pen marker, pen, scissor, double tick, thread, tape and battery. Look for one battery is 36 grams.
Moving on to the apparatus and materials. The apparatus and materials that I use are sponge, 15 cm and 30 cm ruler, protractor, thread, 50 gram, 150 gram and 200 gram of soil.
My experiment setup for S1 torsion. The chopstick has been sellotaped at the corner of the table. The chopstick is attached with the span stick and the cardboard had been cut at the circular hole. Finally, and the rope had been sellotaped around the cardboard and the load is ready to hang. The degree had to be in 0 before we weight the load.
So now we go to the procedure. Take a cardboard or box that has been cut around and tape it with string. Tape it with tape. Take the box and make a hole around here. Make a hole using scissors. Take another cardboard and make a hole around here and make it using a scissor. This is a box that has been made a hole and put the cardboard into it. Next, insert wood into the hole. Insert the round cardboard into the wood. Tie the stone with the rope and make sure it's tied tightly. Drop the stone and the wooden stick will rotate. Take a measure and it shows 50 degrees. We go through 35 grams of stone. Okay, this is a 35 grams of stone and we tie with rope and make sure it's tied tightly. Also, we drop it and the wooden stick will rotate. Take the measure and it shows 40 degrees. 60 grams of stone. Tie the stone with rope and also make sure it's tied tightly. Drop it and the wooden stick will rotate. And take the measure and it shows 60 degrees.
Okay, next is procedure. Firstly, take the pieces of board and make a hole in the middle. Next, take another board and make a hole in the middle also. And try to put wooden stick into the hole and then put the pieces board into the board. And then put the circle board into the wooden stick. Okay, next, place the tape on the top of circle board and tie the battery tightly using a rope. Drop the stone and we will see the wooden stick will rotate, and last take the measure.
Okay, for the first setup, we use the 90-degree angle and mark here, and we take the load. For the first setup, we use 36 gram load and we drop the load, and we mark the movement. At the 90 degree, the new 90-degree result. We mark here. Okay. And we check the angle. Before we check angle, you see, we draw the line on the CD, the location at we mark. And this is for the original 90 degree. Okay, and we see the result. Now we can see is the torsion movement is 5 degree. This is result for the setup 1. Okay, for the second setup, we mark the 90-degree angle at here, and we use 72 gram Look, and we drop the load. We mark the new 90 degree. After we mark, we measure the angle of the load. And we check. Okay, the angle is 37 degree. Okay, for the third setup, we mark the 90 degree angle here, and for the third setup, we use 108 gram load, and we drop the load. And we can see the torsion movement here. Okay, after the movement stop, we use the protector and take the new 90 degree angle. Okay. And we mark the new angle here. And we measure it. For the third setup, the result is 50 degree.
Moving on to the method and procedure. 50 gram of soil are weighed on a weight scale and put into a plastic bag. Next, the 50 gram of soil is tied with a rope and hung onto the sponge. The rotation of the sponge is measured and the data is recorded. Lastly, repeat the number 1, 2, and 3 steps with 150 gram and 200 gram of soil. So for the 50 gram of soil, firstly I hang the soil to the sponge with thread, and then the angle of rotation is measured with a pencil. Then moving on to the 150 gram of soil, I hang the 150 gram of soil to the sponge, and then the angle of rotation is measured. And lastly, for the 200 gram of soil, this is how it is done.